Hi there, my name is Troy Deploy, and this is my Project Day presentation for my Honours Year project. I'm doing my honours in computer science with specialization in artificial intelligence. I'm also a DJ and a producer that is passionate about music. Problem background. Recommendation systems today are commonplace. You can find them in online stores and movie recommendation, things like Netflix and YouTube and things like that, and you can also find them within music streaming platforms. In music streaming platforms, there are primarily three different types of recommendation systems. Collaborative filtering systems that make recommendations based on the similarity of users, i.e. if user A and user B are similar users to one another and user B likes a song, it's likely that user A will also like that song. Content-based filtering systems, which makes recommendation based on the similarity of songs in terms of audio content. For instance, if user A likes song A and song A is similar to song B in terms of audio content, it is likely that user A will like song B. Then there are also hybrid systems which leverage both user similarity data as well as audio content similarity data. These recommendation systems on music streaming platforms cater to the general music listener. However, few of them cater to the specific needs of DJs, which includes knowledge about the keys of the songs and beats per minute and other things like that. The research question for my project is, can autoencoders be used to effectively recommend songs to DJs? The proposed system is to use an autoencoder, which is a form of neural network that takes inputs, compresses it down to a smaller size, and then reconstructs it. And in doing so, learns ways to compress the inputs in a meaningful way that keeps the most important information in the input. And then, take the autoencoder, or specifically the encoder section, generate latent space embeddings, which is basically just that compressed representation of all the data that I spoke about. It's a type of vector, which is just a list of numbers fundamentally. Then generate the latent space embeddings for that, and then traverse the latent space, or traverse the set of all these different compressed vectors for the songs. And then we use that to make recommendations. And we do that by finding the path that is of the shortest length that goes through all of the different embeddings we have gotten. So what makes my system unique? My system is specifically for DJs. It is purely content-based, meaning that it ignores popularity, which is good for providing opportunity for more underground tracks. It also pays more attention to song features, which results in transitions. The logic behind this is that if two songs have similar features to one another, that means that the transition between those two songs will likely be quite smooth. It also takes a single track inputs as the C track versus some other systems which take multiple, and it is also a zero-shot classification system. For input, we input the data of a bunch of tracks, which we are going to play in a set, as well as the seed track, which is the first track that you're going to play. The data we input is the key, the mode, BPM, danceability, energy, loudness, valence, and instrumentalness. And then we input some low-level features, such as the chroma values, which are a representation of the pitches in the songs, the pitches of notes in songs. For processing this data, before it goes to the model, we represent the key and the mode in a intelligent fashion, circular, according to the circle of fifths. This is demonstrated over on the right-hand side of the slide. So the songs that are a fifth apart from one another, or are the relative major or minor of a specific key, are linked to one another. As you can see, B flat minor is linked to F minor, which is a fifth down from it, but it is also linked to C sharp major, which is relative major for it. Then we represent the BPM of a song in a similar circular fashion. And this is done so that if you have a track that is 160 BPM and a song that is half time of that, which will be at 80 BPM, they can be recommended to one another, as you can mix a song in DJ that is 160 BPM with a song that's 80 BPM. And then finally, we normalize all of the inputs given to us. We also take the low-level features, but we only take the first 16 chroma values for our input. So once we've gotten all this data, we obtain the latent space embedding by feeding all of this data into the encoder section of our autoencoder. We store it in a vector database, and then when a DJ wants to play a set, he selects all the tracks that he wants to play and sets a C track. These are then retrieved from the vector database, and then the latent space that all of these different embeddings from the selected tracks are in is then traversed to find the shortest path between them to ensure the smoothest transitions throughout the set. An output is an ordered list of tracks, which is we refer to it as the recommendation path. It is the path that is the recommended order for the DJ to play the tracks in each set. So my project has different pipelines, and these pipelines differ. Some pipelines find the exact path, the exact path that is the shortest distance using the Halt-Carp algorithm. And some of them find a path that is quite short, but not exactly the shortest possible path, using the greedy nearest neighbor algorithm. So the latent space dimensionality in all of these things is 64-dimensional, which sounds like quite large, but the input to the neural network is at least 202-dimensional, so it is a massive reduction in size. And some of the pipelines are implemented with my own handwritten code, and others are implemented using libraries, but all of this is done in Python. So why should we do things this way? The autoencoder is effective for dimensionality reduction, as we discussed earlier. It is also able to capture complex relationships because it is a neural network and can support non-linearity. Latent space embedding is a simple and elegant technique, and it also is supported by the idea that more similar tracks to one another, which will be closer to one another in the latent space, will result in smoother transitions if you play those tracks one after the other. Thank you very much. That's the introduction to my project. And now I shall show you a demo of my system. So my system is called Algorhythm. We go in here, we can add a track. This track is an Afro-tech song by DJ Merlin and Ian Upper called Two Zulu Men in Ibiza. It was one of my favorite songs that year when it came out, which was 2022. I've also seen Ian Upper live, and he's pretty great. And then we go to this. This is just the data over here. I remember this off the top of my head. Sorry about that. It's an A major. It's 120 BPM. These scores are obtained from the Spotify API. You can also get them from a website like chozic.com. Then we so this over here, we upload the actual audio file of the song so that it can extract those chroma values from it. Then we upload it. It'll take a couple of seconds because it takes a while to extract all those chroma values. And the track has been successfully added. Right. And now what we can also do is the track. We can go here. We can edit the song. This is just a small example. Let's just change it to Two Zulu Men. Submit. And then if we go back to it, we shall see that, yeah, the name is updated. We can also delete the song, but we're not going to delete it. Now let me give you a demonstration of how the thing works in practice. So let us take as the C track my Two Zulu Men song. Choose that as the seed song. Now over here we just simply select the tracks for the set. So let's just go with that. Let's go further on. All of these get added to one another. I love acid. Okay, and then we go here, we submit. And we can listen to the song over here, for instance. Here we go. And then what we can do is we can view the unplayed tracks in our set. These are the tracks that we haven't played yet in our set. We can add other tracks if we're running out of tracks and we need to play more tracks. Let's go in the watch. As you shall see, this is updated now. And then what we can do is we can choose the song that we have played now by selecting this update button, submit, and you'll see it will provide the next track that is recommended. And then you can choose songs you can choose the recommended track if you want to, or you can choose a completely different track if you would like to, because you, with your own personal discretion, believe that a certain track will be better to play. And then we can play all the tracks. I can do that, and once we get to the end of the set, we can either select all the songs and go through the list completely, or we can just select finish set. And yeah, that is pretty much my system. I hope you have a lovely day, and goodbye.